Cool. Okay, so let's get started. We have a really tight agenda, so I'm just going to kind of quickly go over what we're going to do. We're going to take a quick look at what agents and protocols are, so everyone gets up to speed. We'll do overview of the MCP architecture. We'll have showcase with Daniel. Then we'll do the workshop. So the first three things are supposed to be kind of the first 15-ish minutes, and then we'll start the workshop right away. And then at the end, we'll have Q&A after the workshop, and even during workshop. If you have any questions, you can ask one of us on what to do. Karen already introduced me. My name is Milan, co-founder and CEO of Keyflow. And at Keyflow, we productionize agentic systems for enterprises and businesses. So MCP is really close to us because it was introduced in November 25, and I was following the agent space very closely. I read the whole thing the day it came out, tweeted how cool it was, had a conversation with Win, also someone who hosts, and just kind of tweeted this out. It's a really amazing protocol. Didn't fully understand it yet, but I know this is needed because I see a gap in the market for it to exist. So let's do a quick understanding of how AI systems have evolved over time. And over time, meaning since 2022, right? People were using GPT in 2020, but the AI revolution really started in 2022 after ChatGPT. So after ChatGPT's success, we had deterministic flows. That's how we were using these large language models in the systems. Basically, we had something that humans planned, a process that humans planned on what the code needs to do, and then we would put AI calls in between where we needed intelligence. So we would decide where we need intelligence in the system. And that was the very first evolution of AI workflows, AI process, deterministic flows, doing work for us and using AI. And you could create systems with deterministic flows that felt like agents. Then we came with, then OpenAI introduced tools 6 months-ish later. And with tools, basically what we had is LLMs that can call tools, that can maybe even call files for retrieval or have access to memory. And here, instead of people planning the process or humans planning the exact process of what calls LLM needs to do, LLM decides based on the tools it has what it needs to do. And it could even do some sort of iteration, so you could say, okay, iterate like 5 times and figure out how to get to a response. Right? So we had smaller processes that were being done by these LLM tools. Then finally, we had stage 3, which is what we have today. So you guys have probably heard of Cursor and Windsurf, and they implement something we call agent loops. So the difference between step 2 and step 3 is that in step 3, we actually have an environment for self-verification, and your LLM with tools will take some action. That action will then be checked against some sort of environment. So in this case, when Cursor agent is developing your software or code for you, you have lint errors, and then Cursor would say, I see there's a lint error, let me go and fix that, right? So it's interacting with the environment, which is the IDE, to fix itself, and that's the first use case, production use case of what we have seen an agent loop actually working in production. So that's very quickly the 3 stages of AI development that we have gone through so far. Now, there are some problems with current agent development. So developers must build everything themselves. If I'm trying to build an agent, I need to build the agent, I need to build the tools, I need to build integrations, authentication with those integrations, everything. So that's one of the very big problems today. And you can see if there's 3 apps being developed, every single piece is being developed by the teams of these 3 different companies, right? So you're kind of like doing a lot of same sort of code is being written over and over again. The second problem, which is part of the first problem, is that that's leading to fragmented effort. We have the best mind in the world trying to build an agent that works for their company. And we should be using this best minds to just build this one particular system so that at the end of the day, the end user gets the best experience. So that's not what's happening today. Developers are just kind of stuck building every single part of the system. And then finally, we have poor control on the data shared with LLMs. Because these companies are doing the end-to-end system today, there is no official standard documentation or standard protocol or standard agreement, a foundational agreement on how to build these things and how the data security looks like. And we have to kind of just trust the companies on the data security layer right now. So there's a need for some sort of foundational agreement on how agents are being developed. And basically foundational agreements are what protocols are. And we have seen protocols before as well. So there are foundational agreements and how system communicates, right? Like that's basically the fundamental of what a protocol means. Protocol helps people collaborate at scale because now we know that this is the way systems are supposed to communicate. We can go and build things separately and they're just going to fit in with all the other systems that exist out there. And we have seen numerous examples of protocol developed over time. The most popular being TCP and HTTP that created the backbone of the internet today. So because of HTTP now, you can go and build a website and that website can exist in the World Wide Web and people can interact with it. Because that protocol defines the communication between the browser and the server on how the web pages should be served by the server. And then one thing we have to keep in mind as we move to the MCP architecture moving forward is protocols are also constantly evolving. There's nothing that you just type once and you say this is the protocol and this is how things needs to be done. Right? HTTP, when it first came out, was just 0.9 version. It only had GET request implemented. And over time, as people started building on it, and more people joined the HTTP revolution, we got to HTTP 3 in 2019. And even in 2022, there's one more update to HTTP 3. So protocols evolve over time as our needs evolve over time. And this is something to keep in mind because MCP is at the HTTP 0.9 stage today. So now we'll get into the meaty part of it. What does model context protocol really solve? And the name suggests, the name is a really good definition of it. If we are trying to solve context management for agents or AI or any sort of large language model, the best way to get results out of LLMs is to pass in the right context. And so with MCP, this protocol, we're just trying to figure out how do we model the context that it needs to do its work, while keeping security, while keeping other things in consideration as well. So fundamentally, Bill likes to ask this question, fundamentally what is something? So fundamentally, what is MCP? It's just this 2077 or 2076 line of code JSON file, right? Protocols are basically just rules, so there's no logic that is being implemented, it's just rules on how we are supposed to communicate. We are supposed to get models to communicate with other services out there. And the MCP protocol defines these three main things. There's a host, client, and a server. So this is the image from MCP spec. And you can see there's a host. Host here is an application like Claude or Cursor or Windsurf or any AI agent script that can also be a host. Anything that's using large language models and implementing clients inside it can be considered as a host. So client, on the other hand, for MCP is something that keeps a one-to-one connection with servers. So one host can have multiple clients if it needs to talk to multiple servers. And that solves the problem of an agent being able to connect to as many tools as it wants. So then we can define multiple clients, and then those clients will talk to individual servers. Now this is a little bit too technical, so we'll go in a more fun definition that is described by ByteByteGo. This is a really cool resource that I follow. They have really good explanations of everything. So the way I like to think about MCP is you have these two things, client and server, that are the most important things. And you can think of anytime you implement MCP client, you are giving, let's say, a male USB part to your application. Anytime you build an MCP server, you're giving a female USB part to an application. And now your application can just be put on the internet, and anyone with like the client implementation can connect to your server, right? Same thing happens when you develop a client and there are all the servers out there. Your client, once you implement the MCP client USB part, you can connect to all the servers out there. So you can just focus on either developing the best AI agent, you can just focus on developing the best services for the AI agent, right? You can kind of fragment your development process. And this is like the USB part, this is the USB part, right? And then your server talks to different apps. It can talk to cloud services, databases, it can talk to any applications. Your clients can talk to the applications that run on your computer, web browser, scripts, anywhere. Like, so it can run on the server, this can run on the server. The running part doesn't really matter. What matters is where the agent sits, where the large language model sits, and where it doesn't sit. So now we have this client. So you can see there are some things that are exposed. What people are really excited about is this thing today here, the tools that the clients expose. So when you're writing a server, you're basically exposing a set of tools to whatever client exists out there, right? So today we are going to be developing an MCP server. We are going to write some tools for it, and that tool will give it access to the cursor agent that exists out there, right? It's already in production. Your server can also expose prompt and resources, and these are like the two things that there's no use to developing it right now because there are no good clients that actually use prompts and resources really well. So even if you develop this, there just don't exist good clients out there that are doing that. There's also secure file and sampling that clients can expose, and we can go into that in Q&A if someone has questions about it, but we're gonna skip past this so we can get to the last fun part. So now, why is this protocol so important? What is so groundbreaking about it? Why are people just raving about it? A part of it is Twitter hype, but a part of it is also because it unlocks something what I call as network of agents for the future, right? So now that people can develop either services in Silo or the agent in Silo, and Cursor actually proved this. People have built Figma Cursor, Figma MCP, people have built Blender MCP, and they just built this like lightweight server. They connected it to Cursor, and Cursor was able to take actions and build stuff out of it by just people talking to it. So that's a really good proof of concept that you can develop things in Silo, you can develop an AI agent loop in Silo, and you can develop your services in Silo. And if you just kind of connect it, it will start magically working because LLMs are magical. So this will allow network of agents because one of the things that is not defined in the protocol, which I think is not very well known, but is that you can have a service that has both client and server implementation. So you can think of like my iPhone, right? It has a female USB part or female lightning part, but I can also attach a male lightning part to that device, and now it can charge other people's device or it can get charged. So basically that's what you can do. You can create a service, you can create an MCP server, but inside your server you have client implementation, which means your server can call other clients. So your server can call other servers through your client. And same way, other people can do the same thing, and now you can see that people are developing these separate agents out there, and users sitting somewhere. He's talking to his personal assistant agent, and that personal assistant agent is going out and doing work with other agents, and people just need to develop these things in Silo. So that's one of the really cool side effects that's going to happen very soon because the protocol is being developed, and right now there's no remote servers. As soon as remote servers hit, we are going to see this explosion of like a network of agents that's going to start building up. The second thing is like the example that I was talking about is like you can have an orchestration agent, you can have an analysis agent, coding agent, research agent, etc. Right, and you can just have this network keep creating itself as people bring more servers online. There's remote servers coming, as I said, and then there's also authentication coming. So once we have remote servers, you would want to connect your Notion or Slack or any app, and these servers will allow in the protocol how to do OAuth and how to securely access, do token access transmission between these clients and servers. Then there's also going to be an official registry that's coming up from Anthropic. So you'll be seeing a lot of registry that people are posting, but they're all going to be dead soon. Anthropic is doing their own. It's going to solve discovery, so when you want to find MCP agents, you can easily just go through this official registry. They will have verification, so Shopify, if they build an MCP agent now, they'll talk to Anthropic, get a verified logo, and then now your agents will know that this is the verified Shopify MCP. So that's also coming, that's really exciting, and it will be all centralized, which is cool. This registry will also enable self-evolving agents, right? So your agent might not have a specific server installed, but now it can go to the registry and it can figure out which server it needs to install that, do the work, get results back to you. So that's also cool. And the way I am thinking of simply doing this is...
Before you go on, that's, first of all, that's cool. What do you think do you feel like this is like early internet before there were like a lot of websites? Like the browser was barely invented, so the browser was like the first HTTP client, or like early Netscape days, there weren't really that many websites, right? Like, would you liken it to that era of computing? We had to like use an analogy to understand it. why this is important.
Yeah.
Right? Like, is that an example? Does that analogy like
That's
make
actually
sense,
very,
or would it like where does it fall apart?
very accurate analogy. Right now we have about, I think, if you go, there are probably around like 10,000 servers that people have just kind of built. But think of it as like when people were building websites, the internet wasn't up. So people just had websites and they were just kind of testing out what it would look like on their local computer. That's what's happening.
Yeah.
And also, out of these 10,000 servers, not every single server is actually built with care, right? People are just kind of building and posting it, and the rough estimate is 10,000 servers. So the network is not even up yet, but it's coming like literally in a month or two. And this is almost as if like the World Wide Web is going to go live in 2 months. That's where I think we are, which is very cool.
Do you feel like that registry should be centralized or decentralized?
So I think there's going to be a lot of people trying to do registry because it's never going to be that one company owns everything. But Anthropic, because they did the protocol, they will have a lot of reputation. And also they are kind of developers' favorite company when it comes to LLMs. And they have this reputation of being honest and truthful. We are going to trust it more. So there's going to be decentralized registry anyways, but we are just going to get people who are going to try and centralize it, and there's going to be pockets of it, for sure.
Any other questions so far?
Where does the trust part come in when it comes to registry? Like, is it similar to like browser versus like Chrome versus Brave, or like how does the trust part?
Yeah, I should have explained the sampling there. So basically, I talked about how client and server are two different things, right? And in server, when let's say I'm developing a server today, and in my server I need to call an LLM, right? In my server code I need to call some sort of LLM to do some processing. I have two options. I can just call OpenAI API, but I'm leaking the data to OpenAI now, right? My server is doing that. My server, when it gets audited for the code, it will see, like the people who have the registry will see that you'll give me maybe D or F in the license form. So my server will show that this is like leaking data from here, right? Like the same way App Store has that. But what I can also do is I can use sampling, which what the client exposed, and my server can request the client and say, I want to use LLM, this is the request that I want to send. The client will execute the request and give the response back to server. And then server can go. So think of this when it comes to enterprises. Enterprises have their own private deployment of LLMs, and those LLMs will be exposed via clients. And they will be talking to all these different servers out there, and there's the, let's say, Slack's official server out there. The enterprise client will get a request from Slack server saying, hey, I want to use LLM. Here's the information you should call. So now you have two officially verified, like your enterprise deals with Slack, and there's a legal team that handles all that. And Slack is never sending any data to third party. Slack can always use your own large language model. So that's how security is solved. Yeah.
So you say, thanks by the way. So the registry that you're talking about, is that going to be like repos or containers that you download and run, execute somewhere you choose, or do you think that Anthropic is going to host them and code executes on their hosts?
No, so the hosting, right now all the code is local, right? So people are just kind of uploading their GitHub, but that's not what it's going to be. For example, my company, Keyflow, when we do MCP, we're going to only do remote hosted. So in our platform, you can come and kind of orchestrate an agent workflow, right? You can say, I want to read the PDF, do Google search on the founders, like XYZ, whatever you want to do. We can expose that entire workflow via MCP server. That's our hosted local, or hosted remotely. So every company can host their own remote servers. And there will be open source servers that people can just kind of containerize and run it on whatever compute that they want. But it depends if like Slack is going to allow us to do that, right? Maybe Slack does an enterprise deal and they can give you a containerized server, but most of the time, the economies of scale says that if the company who is developing the server hosts it, they are going to be the most profitable one.
So it's like Slack is going to host that server, it's just going to allow any model to call it.
Exactly. But the way Slack hosts their backend, they're going to start hosting MCP servers for the agents. Yeah. Yeah. Go ahead.
Will MCP obviate stuff like line graph or crew AI, or just decompose it with crew AI, existing long-range models?
That's a really good question. So MCP doesn't really, like, in the protocol layer, if you go in the specs a little bit, which we can go in the last Q&A, at the end of the Q&A, The MCP protocol just says, hey, here's how a client can talk to a server, how a server can talk to a client. They don't, and they expose certain things. So they say, a server has a list of tools, prompts, and resources. Hey client, this is how you can request that. That's all it's saying. Turns out that's all you need to build an agent, right? So LangGraph is solving a completely different problem, is how do you do agent orchestration? But all those agents are the first way of agent development. You're building the tools, everything yourself, and they solved the problem for something that they didn't kind of like see that this was going to be how world is going to change. So Anthropic team really thought hard and said, okay, what do we really need to do to get all the best minds working in collaboration at scale? And sort of like having a protocol was the answer instead of having a framework to build agents. Right, so there are separate things. LangGraph can implement an MCP client on their agents, right? So you can have this complex LangGraph agent. You can put it in a server, you can put it in a client, whatever you want to do. Doesn't really matter. But that's just the code that's running inside the function. If they want their thing to be exposed to this internet, they need to plug in with MCP somehow.
I think you mentioned remote servers aren't out yet. And they're like not. What's the blocker? Is it more just people are working on it, or is there like a technical blocker or something like that?
A chicken and an egg problem. So Cloudflare, I just saw a tweet yesterday from Cloudflare. They mentioned that you can now do a remote server on MCP. So the protocol has defined how you can do remote servers. There literally is no client. So someone asked in their comments, what client can I use it with? They said literally no client right now. So there's no client that can do the protocol to execute the remote servers yet. But what I'm saying is a month is because Cloudflare was working on remote servers. So the protocol is being updated constantly. And essentially there's like a 1 to 2 month developer lag where developers look at that, they try to build something and they'll productionize it. And yeah.
There's a lot more servers coming up right now, and I think the clients take a little bit more time just to get out there. Because there isn't as much we can do something. But it's I think even ChatGPT announced, or OpenAI announced today they're supporting MCP in all their products, whatever that is going to
5 hours ago, yeah.
Yeah, 5 hours, exactly. So we'll see what happens, what that actually means. Yeah, that's really exciting. How are we doing for time?
I think we're good. We are pretty much done with this thing. I was just going to showcase like people build these kind of workflows on our platform, right? You can have an AI being you can read a PDF page by page using VLMs. You can do deep research, you can extract data, do Google search, and then you can create a report at the end, right? And what I can do, if I want to expose this to all the MCP clients or all the apps that use MCP, I can just make this, package this into a server. So I can make it very easy where I can just do one-click deploy and make this an MCP server. And now anyone can connect their actual workflows, which are deterministic a little bit more, and every single one is an agent that's doing handoff. So that's how we are going to be thinking about it moving forward. And that is everything. That's my Twitter. If you guys want to talk about MCP or any agent stuff in the future, you can follow there. And yeah, that's pretty much it. We'll start with, actually, Daniel.
So let's, Milan first, thanks for this overview. I know there's a lot of concepts here that we covered, and there's a lot of interesting stuff here. There's a lot of questions as well, I'm sure. I think because this is a standard, I thought it would be interesting for us to bring in folks that have implemented MCP in real world scenarios in production. So we have Daniel Hassan, who's the founder of LegalFlow, who's going to talk about how they are thinking about what LegalFlow is and how they're thinking about it. We'll also have space at the end of this. If there's anyone else that has built with MCP and wants to talk about how they have done it or has had some practice with it, please feel free. So Daniel, I'm going to hand it over to you to maybe talk about how you're